12 men walked on the moon. Between 1969 and 1972, Apollo sent them there 6 times. They brought back 842 pounds of rock. They planted flags. They drove a rover across the surface. They hit golf balls. They left seismometers and retroreflectors and footprints that are still there right now, perfectly preserved in a place where nothing erodes and nothing changes. And when it was over, we built an entire model of the moon based on what they found. That model has been our definitive understanding of the moon for 53 years. There is just one problem with it. Every single Apollo astronaut who reached the moon did so on a trajectory specifically designed to keep them away from most of it. Not by accident, not by negligence, by necessity. And that decision, made for completely logical reasons, in the 1960s, left an enormous blind spot in everything we thought we knew. A blind spot so large it covers an entire hemisphere of the nearest world to our own. Artemis II just flew directly into that blind spot. And what the crew found there in 7 hours on the 6th of April 2026 is already forcing scientists to revise conclusions that have stood unchallenged since before most people alive today were born. Here is exactly what Apollo saw, what it could never see, and what changed the moment Artemis II swept around the far side with human eyes looking out the window. When NASA designed the Apollo missions, one priority overrode everything else: land astronauts on the lunar surface and bring them home alive. Every other consideration was secondary to that, which meant launching into windows where the near side of the moon, the side that permanently faces Earth, was fully illuminated by sunlight, because the near side was where the landing sites were. That was where the astronauts were going. That was what the entire program was built around. The consequence of that decision was invisible at the time and largely forgotten since. When the Apollo command modules orbited the moon, waiting in lunar orbit while the landers descended and returned, the far side was in darkness, not partially lit, not dimly visible, in complete darkness. The timing of their launches, calculated to put sunlight on the near side for the landings, meant the sun was on the opposite side of the moon for the entire duration of their orbital observations. Kelsey Young, the Artemis II lunar science lead, said this plainly at a pre-mission press conference. She said that when the Apollo missions launched, they prioritized windows where the near side was illuminated because that is where the missions landed. The far side was not illuminated at the time when they were in orbit. That single sentence contains the entire limitation of 50 years of crude lunar science. 12 people walked on the moon. 0 of them ever saw most of it. Now add the second limitation, the one that compounds the first. Apollo command modules orbited the moon at an altitude of approximately 70 miles above the surface, 60 to 70 miles. That is close enough to see individual boulders in sharp relief, close enough to feel the pull of local gravity anomalies called mascons, concentrations of dense material beneath the surface that bent the orbital trajectories in ways that confused mission planners until they figured out what was causing it. That closeness had a cost nobody talks about. At 70 miles, you can see extraordinary detail on a narrow strip of terrain directly below you, but you cannot see the whole moon at once. The curvature of the lunar horizon cuts off your field of view on every side. You are looking through a narrow window at a moving ribbon of surface passing beneath you, never the full picture, never the complete context. The Artemis II spacecraft flew at 4,067 miles above the surface at closest approach. Not 70. 4,067. At that altitude, the entire lunar disk fits within a single field of view. The crew described it as seeing the moon the way you see a basketball held at arm's length, the full sphere, both hemispheres simultaneously. Features on the limb, visible in context with features at the center. Something no Apollo crew ever experienced while actually at the moon. Apollo astronauts never saw their destination that way, not once across 12 missions. And that difference in perspective, that one change in altitude and orbital geometry, revealed something in the first few hours of the Artemis II flyby that no amount of prior data had made obvious. The two hemispheres of the moon do not look like the same world. Before the flyby even officially began, on the evening of April 5th, the Artemis II crew was already seeing things Apollo never could. Using a 400mm telephoto lens pointed at the moon from more than 2/3 of the distance to it, they began identifying features that no human eyes had ever seen directly. One of those features stopped mission control completely. The Orientale Basin, a 600-kilometer impact scar, 3.5 billion years old, straddling the exact boundary between the near and far sides of the moon. From Earth, it is permanently hidden just past the lunar limb. No Apollo crew ever photographed it with human-operated cameras. No human eyes had ever seen it. The Artemis II crew spotted it before they even reached the moon. Mission Control described the crew's emotional state during this approach with 2 words: moon joy. That was the official phrase. It does not fully describe what was actually happening. These are people trained to observe and report with precision under pressure. And something about what they were seeing through that telephoto lens was producing a reaction that cut through the professional detachment. Christina Koch described it in an interview from orbit the following day. She said, looking out the window at the moon, "Something felt wrong. The darker parts were not quite in the right place." Her words were that it was not the moon she was used to seeing. Think about what that means coming from her. Koch spent 168 days aboard the International Space Station. She has seen the moon from orbit before. She knows exactly what it looks like from space. And her first instinct when she looked at the far side was that something about the fundamental structure of the object was off. She was right. And here is why. The Apollo model of the moon was built entirely from near-side observations, with occasional orbital passes over a far side shrouded in darkness. That model treated the two hemispheres as regional variations of a unified body. Similar geology, similar history, similar structure, just with some differences in surface detail. That assumption was wrong. The near side, which every Apollo mission studied exhaustively, is roughly 31% covered in vast flat plains of ancient volcanic basalt. The Maria, dark, smooth, the product of lava flows that poured into enormous impact craters billions of years ago, filled them completely, cooled and solidified. That is what gives the moon its face. Those dark plains are what every human civilization ever born has been staring at. The far side has less than 1%. Instead of smooth volcanic plains, the far side is an unbroken wall of craters, stacked on older craters, reaching to every horizon. Every impact the moon has ever received, going back 4 billion years, preserved in perfect detail because nothing ever came to fill the wounds in. No lava. No geological process, just accumulating violence, frozen in place. The crust on the far side is approximately 50 kilometers thicker than on the near side. 50 kilometers. That is not a measurement variation. That is a structural difference, so fundamental it demands an explanation that nobody has yet been able to provide completely. Apollo astronauts, orbiting in darkness over this landscape, had no way to see any of this in context. The instruments on later robotic missions mapped it in data, but data and a human brain looking at both hemispheres simultaneously through a window are two entirely different things. Koch saw the wrongness immediately. Her brain registered the asymmetry before she could articulate what she was looking at. That is the thing instruments cannot replicate. The pattern recognition of a trained human mind encountering something that violates its expectations. Now here is where Apollo and Artemis II diverge most dramatically. Not in what they saw, in what happened when the sun disappeared. The Apollo 17 mission, the last crewed moon landing in December 1972, the most scientifically equipped of all the Apollo missions, carrying the only professional geologist who ever walked on the lunar surface, reported 3 meteoroid impact flashes during the entire duration of their mission. 3 flashes, total, for the whole mission. Those 3 data points were incorporated into scientific models of lunar impact rates. They became part of the foundation for understanding how frequently the moon gets struck, how dangerous the impact environment is, how much risk future surface crews would face. For 53 years, that number has shaped our understanding. During the 7 hours of the Artemis II lunar flyby, as the sun slid behind the moon and the unlit surface became briefly observable against the darkness of space, the crew reported 6 meteoroid impact flashes. 6 in 7 hours. Twice Apollo 17's entire mission count in a fraction of the time. Reed Wiseman's radio transmission when it happened was not the composed voice of a commander logging a routine observation. He said, "That was definitely impact flashes on the moon." And Jeremy just saw another one. Kelsey Young in Houston heard this and did not respond with calibrated scientific acknowledgement. She said she was amazed that she had not expected the crew to see any at all on this mission. Then she described what was happening in the science evaluation room at that exact moment. Audible screams of delight. The mission's backup astronaut, Jenny Gibbons, said the impact flashes were really high-priority science, that the fact that they saw 4 or 5 of them was outstanding. They actually saw 6. The significance here goes beyond excitement. If the Artemis II crew saw 6 impact flashes in 7 hours, while Apollo 17 saw 3 in an entire mission, one of 3 things is true. Either the impact rate is genuinely higher than 5 decades of models assumed, or the training and observing conditions that Artemis II had, specifically the eclipse-darkened surface that made flashes visible in a way daylit Apollo orbits, never allowed created detection conditions Apollo never had access to. Or both are contributing. Either way, the models built on Apollo's 3 data points need revision. And if the lunar surface is being struck more frequently than calculated, the risk assessment for every planned surface habitat, every permanent outpost, every long-duration crew we intend to put on the moon has just changed. There is something else Artemis II saw that Apollo not only never saw, but structurally could never have seen under any of its mission parameters. Earth, leaving. Every Apollo mission maintained relatively continuous contact with Earth throughout the lunar orbit phase. The communications blackout during far-side passes lasted only a few minutes. Earth was always either visible or seconds away from becoming visible again. The emotional reality of Earth as home, as anchor, as the thing you were coming back to, was never in doubt because it was always right there. On the 6th of April 2026, the Artemis II crew watched Earth set behind the moon's horizon and disappear. Not slip behind a crater rim, not dip below the curvature for a few minutes, disappear. A pale blue crescent, still showing cloud cover over Australia and Oceania on its sunlit face, sinking behind grey rock until there was nothing left but the ancient battered surface of the far side and the silence. They named that photograph Earthset. It is the precise visual inversion of Earthrise, the photograph Bill Anders captured from Apollo 8 inches December 1968, showing Earth rising above the lunar horizon. That image arrived, appeared, came into view. The moment it was beamed back to Earth, it changed how humanity thought about the planet it lived on. The fragility, the loneliness, the pale blue presence suspended in black space. Earthset is the opposite moment, Earth leaving. vanishing behind a world that does not care whether it exists or not. No Apollo astronaut ever experienced this. The trajectories never created this geometry. It required flying at a higher altitude on a different kind of path with a different observing window. All the things that made Artemis II distinct from Apollo also made this moment possible for the first time. Christina Koch described what happened inside her when she saw it. She said that when you have that perspective and compare it to home, it reminds you how much we have in common, that everything we need, Earth provides, and that you cannot truly understand that until you have had the perspective of the other. That is not science. That is something harder to quantify and more durable than data. Before the communications signal cut out, the capsule communicator in Houston said something to the crew that received almost no coverage in the news. From all of us, it is a privilege to witness you carrying the fire past our farthest reach. Godspeed. Carrying the fire. An old phrase for what explorers do. They keep human knowledge alive by taking it somewhere it has never been. The Apollo crews carried it to the surface of the moon 6 times. Artemis II carried it around the hemisphere that had been facing away from us, unseen, for the entirety of recorded human history. When the signal returned 40 minutes later, the crew brought back something no robotic mission, no orbital satellite, no instrument array has ever been able to retrieve from that place. Kelsey Young, in a moment of unusual directness for a NASA scientist at a press conference, was asked what the most valuable scientific output of the Artemis II flyby would be. She said it was not the photographs, not the spectrometer readings, not the eclipse observations. She said crew descriptions were the highest priority dataset of the entire mission. The human voice, describing what human eyes see in real time, making color calls that cameras flatten, catching texture that sensors miss, noticing things that are not on the prepared observation list, because a trained mind flagged something unexpected. It was Harrison Schmidt's human eyes that caught the orange soil on the lunar surface during Apollo 17, a discovery that nobody had predicted, that the instruments alone would never have flagged, that later rewrote the timeline of volcanic activity on the moon by revealing that eruptions continued far longer than anyone had calculated. One human observation changed a foundational assumption about lunar history. Artemis II spent 7 hours making those kinds of observations across terrain. Apollo never saw illuminated. The full scientific return from those 7 hours will take years to process. And what comes after Artemis II will be built entirely on what those 4 people saw through the windows of integrity on the 6th of April, 2026. Apollo gave us the near side, the familiar face, the half of the moon that we painted into our mythologies and named our gods after and studied for 53 years until we convinced ourselves we understood it. Artemis II gave us the rest. The rest does not match the model. Every answer the far side gives opens 3 more questions. The asymmetry that no single theory explains cleanly. The buried metallic mass that warps the local gravity field. The granite that should not exist. The heat source still radiating from a volcano that went silent 3.5 billion years ago. The sealed lava tubes with entrance shafts visible from orbit. The shallow moonquakes in a body we told ourselves was dead. And now, 6 impact flashes in 7 hours from a surface that we calculated was quieter than that. Apollo was the beginning. What we thought was the ending was actually just the beginning of the questions. Artemis II is where the real investigation starts. Thanks for watching, and I'll see you in the next one.